Hello. Good morning. Hope you're fine. It's my privilege to welcome you here to a short lesson to just look at certain few things in mathematics. Come with me as we begin the lesson by moving on to a different session where we can share certain things in common. Yes, welcome here. So let's look at probability as displayed on the screen. What do we mean by probability? Life is full of probability. Life is full of chances. Probability simply means chance. Am I? However, you can take your dictionary, before the video at this point, take your dictionary and go get the meaning of probability, then resume the video. In the precious light that flows on high. Yes, in life there are two things: death or stay alive. That is the possibility, that's the chances. Now, if you die, it is possible you go to hell or heaven. That is probability. The blood that flows on Calvary. So we are going. It's possible we go to hell or heaven, but we should aim at going to heaven. That is the probability. The one we are considering is to go to heaven. So let's move on by looking at the meaning of probability. Hope you have found a meaning in your dictionary. What is the meaning of probability? Let's look at some few definition or explanation I have put across. You can also read that alongside what you can see in your dictionary. When we say probability, it means the chance or likelihood of an event occurring. What do we mean by that? Let me give a scenario. If you enter a room packed with human beings, there are chances that those human beings are going to be female or male. There's chances that those people are going to be mixed of male and female. So that is what we mean by probability. The likelihood or the chance of an event occurring. If you decide to do business, buy and sell as a human being, you are either going to make profits or you fail the business. So the number of ways you can do the business and achieve success is what we mean by probability. Because you can do the same business, if not properly done, you fail. So in business, you have success and failure. Put the two together is the possible outcome, meaning you can fail or you can succeed in the business. However, if you aim at succeeding in that business, then the number of ways you have achieving that success is what we calculate as probability. So that is the formula for calculating probability. Let's make it simple. The likelihood of an event occurring, that's the probability of that event occurring, is P into brackets E. What do we mean by that event? if you enter a room made up of male and female, and you decide to select a male out of the number without looking, then it depends on the number of male in that room out of the total number of people packed there. So you will succeed, or the successful way of getting a male will be equal to the number of male in that room divided by the total number of human beings there. So that's what we mean by successful outcome. What we are looking at, the specific event there is the male. But a possible outcome is that if you are not looking, you can pick a male or a female. That becomes the possible outcome. So the total number of human beings there is the possible outcome. Now, since we are expressing probability by dividing the successful outcome by the possible outcome, then it is giving us a fraction, which we can again convert into decimal. Hope you agree with that. We have already looked at how to simplify fractions and also convert fractions into decimal. So let's move on to look at other events in life that involve probability. We have examples of events involving probability, such as tossing a coin or selecting students at random, as I explained from the beginning, or picking an item from a bag made up of different items. You are likely to pick any of them at random. Let's look at calculations involving probability. Example, if a coin is tossed once. Tossing a coin once, you can have a tail or a head. If you are looking at your chances of getting a head, then the head you are aiming at becomes your successful outcome. However, if you toss that coin, it is possible that a tail will also show up. So you can have a tail or a head. So there are two possible outcomes there. However, if we are looking at our chances of getting the head, then it is the one head out of the two possible outcomes. That will give us a fraction of 1/2. In decimal, 0.5. The same applies to getting a tail. There's only one tail there, so it will be 1/2, which is the same as 0.5. Hope you had that calculation correct. If you didn't, you can try again. 1/2 converting to decimal. You can try that again. Now let's look at the second example. Our example 2 involves a bag containing different colors of balls. We have 2 yellow balls there, 8 white balls, and 12 green balls. You agree with me that if you dip your hand into that bag, you are likely to pick any of them without looking. So, what is the probability that you dip your hand into that bag and you pick a yellow ball? You pick a green or white ball. You don't pick white ball, or you don't pick green ball. Let's look at the way forward. The solution here is that since we have all these balls packed together, then our possible outcome depends on all these balls. So we are going to have all the balls put together as our possible outcome, which is 2 yellow plus 8 white plus 12 green, making 22. Now, our chances of not selecting white means we are going to select either yellow or green. And we have 2 yellow and 12 green. Put that together will give us 14. So the probability of not selecting white is equal to our successful outcome, which is 12 plus 2, which is 14, divided by the possible outcome, which is the total number of balls, being 22. In a simple fraction, 2 will go into both figures and give us 7 out of 11. B, selecting green or white. depends on the number of green and the number of white. We have 12 green and 8 white. If you put that together, that gives us 20. So selecting green or white, our successful outcome will be 20 and possible outcome will be 22. And that will give us 10 out of 11. Hope you had that correct. Let's look at question 3, which says selecting yellow. Here, we also divide the number of yellow balls by the total number of balls, and that will give us 2 yellow over 22 balls, which is the same as 1 over 11. D, not selecting green means selecting either yellow or white ball. We have 2 yellow and 8 white, giving us a total of 10. So we have 10 chances of not selecting green. So that will be 10 over 22, which is the same as 5 over 11. Thank you for your progress. Congratulations if you had that correct. Let's look at another example. That is our third example. And it says, a class of 48 students sat for an examination and 27 of them passed the exam successfully. Find the possibility or probability of selecting a student at random who failed the exam. Here, we don't know or we were not given the number of students that failed the exam. To get that, what do we have to do? You can pause the video here and try that calculation before you watch the next step. Congratulations if you had it correct. Here, to get the number of students that failed the exam, we have to subtract the number of students that passed the examination from the total number of people that sat for the examination. And that will give us 48 minus 27, which is 21. Our possible outcome is to select any of the children, so that is 48. Therefore, we will succeed if we are able to select only the 21 who failed. So our solution here will be 21 over 48, which is the same as 7 over 16 when the two figures are divided by or cancelled by 3. Did you try that? If no, try it again and get back to the video. Our next example is example 4. This involves a frequency table showing a number of children who were born on 25th December in a particular hospital. We have their weight from 8 kg to 14 kg. With respective number of each category listed. Now the question is, what is the probability that selecting a child from this group who weigh less than 8 kg? Weighing less than 8 kg means, weighing less than 11 kg means the child weighs 8, 9, or 10 kg. So we put all the children who weigh 8, 9, and 10 together. Do that addition and see that will be 15 children that weigh 8, 10 children weighing 9 kg, and 9 children weighing 10 kg. Put that together and see what you get before you continue the video. Now let's see if you're able to get your answer correct. The total number of children born there, you have not found that. You have to add all the children together. However, number of children who weigh less than 11 would be 15, 10 plus 9, that's 34. Then, selecting a child at random who weighs less than that figure, or that 11 kg, would be the 34 out of the total number of children born there, which is 86. Hope you had 86 after adding all the figures. Okay, if you had that, congratulations. Now, when we divide this through by 2, we shall have 17 over 43. You can also try converting all these simple fractions into decimal. Thank you for your progress. Let's move to another scenario. You agree with me that the previous scenario that we look at talk about tossing a coin only once. However, we can also have a situation where we can toss the two different coins together. So you have coin 1 in the heading, orange heading, or the red one. Then we have coin 2 on the left column. If you toss coin 1, whatever you see has nothing to do with coin 2, meaning they are operating independently. Therefore, if coin 1 gives you a head, coin 2 can also give you a head. If coin 1 gives you a tail, coin 2 can also give you a tail. But if coin 1 gives you a tail and coin 2 give you head, then you are having tail and head. If coin 1 gives you head and coin 2 give you tail, you are having head and tail. So this shows that we have 4 possible outcomes. From here, question can go like, what is the probability of obtaining the 2 coins giving you the same event? That the same event means both of them showing head, or both of them showing tail. Here we have 2 events that will give us be successful, or that will make us successful. That will be head, tail. So it will be head plus tail. That will give us 2 chances out of the 4. Let's look at tossing a die, or tossing 2 dice together, also at the same time. You agree with me? Just like the coin, both dice will again operate independently. Therefore, the outcome of one die will not affect the outcome of the other die. So what will be the possible outcome? Let's see that. When die 1, the first dice will give us 6 different appearances or faces. Second dice will also give us the same 6 different appearances. Now, matching them, dice 1 can give you 1, whilst die 2 also give you 1. Dice 1 can give you 1, while dice 2 give you 2. That can continue up to 1 and 6. This same scenario can also change, where dice 2 will give you 2, while dice 1 give you 1. Dice 2 can give you 2, while dice 1 give you 2. This also continue through to 2, 6. So you can pause the video at this point, try and do this pairing on your own, and count the number of outcomes that you will achieve. Hope you were able to do that. Thank you. If you're able to achieve or obtain 36 outcomes, then you were successful. So there are 36 possible outcomes in this scenario. Here, further questions can follow, such as how many, or what is the probability that both dice will give us the same number? Here, if both of them give us 1, 1, we have succeeded. 2, 2, we have succeeded. 3, 3, we have succeeded. 4, 4, we have succeeded. 5, 5, we have succeeded. 6, 6, we have succeeded. So there are 6 outcomes here which will make us successful out of the 36. Congratulations, if you had that also correct. Further questions on this, you meet them when you move to the advanced level. Now let's look at questions for your exercise. Question 1. It says in a class of 60 people, 42 are girls. If a pupil is selected at random, what is the probability that it is not a girl? It is not a girl. Let's go to question 2. A bag contains 42 balls, of which 16 are black, 10 white, 4 yellow, and the rest are other colors. If a ball is selected at random from this bag, what is the probability that it is not other colors, it is not black, it is white or yellow, it is yellow or black? Hope you go over this question carefully before attempting it. Let's look at question 3. It involves a frequency table which shows marks obtained by students in a class test. If a student is selected at random again, what is the probability that the student scored the modal mark? Again, the modal mark. The probability that the student scored more than 6, or C, less than 10. If the pass mark for this examination or this class test is 8/10, what is the probability of selecting a student who failed the exam? Thank you. Up to this point, well done for your progress. Thank you so much. Up to this point, I hope you enjoyed this lesson. Take your time, go over the video, and if there's any points you did not understand, you can jot it down and contact me for further explanation. However, try and do your exercise and submit for marking. Thank you and have a good day.